Welcome to Mydbops Open Source Database Meetup-12 edition. To subscribe our channel, press the bell button, like, comment and share.
Hi everyone, good morning. Thanks for joining us in a Saturday, and it's very happy to meet you all after a very long time, after work from home, and welcome to all. I'll not take much time. Let's start the presentation. So today our topic is MySQL operator for InnoDB cluster. So Oracle recently GA'd the InnoDB cluster operator on May 2022. So we'll just have a walkthrough, and at the end of the session we'll have a demo how to set up this cluster on a Google Cloud. Sure. This is just an intro about me. I'll just skip it. Okay, so this is about our company. So what we do, we basically do the consulting services as well as the managed services, and we focus on the top 3 open source databases: MySQL, Mongo, and PostgreSDB. Okay, so this is our agenda. So the trend shifting and the need of the Kubernetes operator, and what does the Oracle MySQL operator brings into the table, and how to be ready for the production setup of the InnoDB cluster. Okay, so recently we saw a trend shift in the market. Like long ago we had the physical machines, and then there was an era of VM when all the systems were moved towards the VM, and now we can see people are moving towards Kubernetes. In the past 3 years or 4 years, down the lane, if you see, all the companies are started to adapt Kubernetes in one way or the other, at least for their application workload. If you see, most of the companies, even recently Mercedes, if you see, they have thrown a blog out of it saying that our workload completely runs on millions of pods. What Kubernetes brings to the table is it's a open source, and you are free to edit and use it, and it was open sourced by Google. It is very much cloud native. It is supported in all the public cloud offerings such as Google, Amazon, and other vendors also. Even you can have your own physical machines and node and set up your own Kubernetes cluster. Sorry. Selva. Sure. Now let's see about what is an operator. So I'll just explain why we need an operator. Sorry for the preview open பண்ணிருக்கேன்.
இது டைரக்ட் ஸ்லைட் ஷேர்.
Sorry for the technical glitch. So let's start again. So Kubernetes helps in the deployment of infrastructure as a code. That means you have a code, and it can be easily deployed through all your application servers as fast as you can, and also it provides the table to bring in rollback as well as the roll forward seamlessly with respect to your application. That is, as pod is the smallest unit of the Kubernetes, when you deploy a cluster, for example, you have a patch management with respect to your application. you are just doing a patch, you just apply the patch onto your pods. It's not the pod which is being recreated with respect to the particular application, and it comes back in a minute, and it provides zero downtime for your application scaling. Okay, so this works well for your application. That means it has been tested in production and it goes well. Now with the change in the trend, now databases also being brought into the circle of Kubernetes with stateful system support, which was recently introduced not long ago, like 1 year back. Okay, so database is a complex system, right? For building a database system, we have to know the product knowledge. That means how to install. The installation varies among the various databases. Like MySQL has a own installation way, Postgres has its own installation way. So product knowledge is very much important to deploy databases as a containerized solution. So that is where the operators come to the picture. Like they provide the intelligence of building a database solution onto a containerized solution. So as we discussed here, so for maintaining a database system, the node should be auto provision, as similar to an application cluster. Whenever there's a node failure or a pod failure, it should be rebuilt. And fault tolerance, like high availability, like a replication or a group cluster or a per connection DB cluster has to be brought in. And backups has to be maintained as a part of this life cycle of the database. And upscaling and downscaling of the nodes, that is node addition as well as the node deletion, has to be done. These are the things that operator provides. Okay, so how this operator supports databases. So if you see application is in stateless. Database is completely stateful. So to support the stateful systems, Kubernetes has this following. First is a persistent volume. It's done by PVC. For example, during the initial stages of Kubernetes, if you see, there is no persistent volume. Whenever there is a node failure, it is completely replaced, and the data which is residing inside that is not anymore needed, because it's an application. It is stateless. For a stateful like database, we need to have a persistent system. That means whenever, even if there is a pod failure, the underlying volume should be present. That means when the next node replaces or the pod replaces, this volume should get attached to that. So that is what is presented by the persistent volume support, or the PVC. PVC is nothing but a persistent volume claim. That's a concept within the Kubernetes. And initialization. For example, to initialize a database, right, we have to check the prerequisite. For example, if it is ready to accept the connection, and other properties has to be checked. So that is provided by the inits of Kubernetes. That is also a probe inside the Kubernetes. And again, you have a cluster. For example, if it is a single node, it's fine. When the init is done, you can just start and you can bring in your application and connect to the DB. And for example, if you have a cluster or a 3-node or a 4-node cluster should work seamlessly, and that is done with the help of the health check. DB has to be monitored properly, whether it is reachable or not reachable. That is done through the probes. There are two types of probes, that is the liveliness probes and the readiness probes. So the readiness probes defines that this node is ready to accept the traffic and you can send the traffic. The liveness probe check the health of the clusters, whether the DB is available or it's not available during the running time. And config maps provides us to help in creating a custom configuration. For example, you might have a physical machine and you are giving your own configurations. You can do via the config maps with the Kubernetes. Okay. Again, coming back to the definition of the Kubernetes. So Kubernetes operator isn't just an extension. You can say Kubernetes operator as an application which lies within the Kubernetes to manage your databases. So all the intelligence which is needed to manage a database is given to the operator. Okay, so there are different stages of operator available in the market. So we have 5 stages. The initial stage will be the phase 1, wherein the stage 1, wherein we'll have the basic installation, and the next stage will be the seamless upgrade. The patching should be available to the operator, and we have till autopilot. So the autopilot is a mode wherein there is no need to, once you deploy the operator, there is no manual intervention. It takes care of itself. So that is a mode of autopilot. And to the fact, we don't have any autopilot right now with respect to the operator. Even the Percona operator, which is in the stage between 3 and 4. Now let's move on to the next slide. So today we will be discussing the Oracle MySQL operator, so which was recently released in May, as I said earlier. So which comes with an Apache 2.0 license. That means you are free to edit your operator. You can patch it, you can add the intelligence and resell it, or you can put it back to the community. And this, as we discussed, it's an level 3 maturity. It has a full lifecycle management, not the autopilot one, and it is completely based upon the GR and the InnoDB cluster. So again, you need a Kubernetes version greater than 1.8. This is because from version 1.8 we have the support for custom resource definition. So our operator uses a custom resource definition. So it's recommended to have a Kubernetes version greater than 1.8. And it was last committed 18 days ago. Okay, so this is a complete architecture what this Kubernetes operator gives you. You can see here, so this is our application connection, just leave about that. So we will discuss from here. The InnoDB cluster provides a router which is to balance the connections across the Kubernetes cluster. And your operator sits at the control plane of the Kubernetes. The control plane completely manages this entire cluster. As we said, it is a part of the lifecycle management. It also provides supports for backup, as well as these backups can be imported and it can be published to a public cloud like Oracle. Here they have given us an object store, which can be an OCA or an S3 bucket also. So this is an official architecture from Oracle itself. So what Oracle InnoDB cluster brings to the table? So Oracle InnoDB cluster, as it is recently introduced, they have a better documentation support for it. And to build a InnoDB cluster using the operator, you need a little knowledge, or just a knowledge just to deploy the operator. It's enough to manage the cluster entirely in the cloud. And it also provides the ability to auto node provision as well as the auto node recovery. For example, if there is a node failure, the node is being automatically replaced by the operator and it is joined back to the cluster itself. And again, the synchronous replication is provided by the GR, that is a group replication. And MySQL router, which is an inbuilt tool which lies within the operator to provide a load balancing across the nodes of the cluster. And backups are taken via MySQL dump, as we discussed in the architecture, and also it is possible to use a clone plugin. The clone plugin comes into the picture for the auto provisioning. Also, it can be used for a backup also, and it supports 8.0. Okay, so what are the things you should consider while using this operator in your production environment? The first thing is you should have a basic knowledge with respect to the Kubernetes. That means at least to patch your operator, check the node status manually, and those things are very needed. And also, the most common corner cases is like, for example, if there is a particular bug, or if there is a particular bug with the operator, you should be able to upgrade the operator. You should be able to manage the patch within the nodes. And in certain cases, with respect to the application, there is a possibility, because everything runs on an application, even database is an application, it's bound to have some bugs. If there is a bug and the cluster goes on in a crash loop, or you need to replace the cluster, or you might be ready to do that. So these are the things, or the basic things you should be knowing while deploying Kubernetes in your production. Okay, as I said, bugs in the operator is very deadly because those completely manages your system. So you should test your operator completely in your QA or a staging environment, and then proceed on to your production. And as we said, it is an and also you should be able to do a performance benchmarking because it is a virtualization layer, which is so there might be performance penalties, and you should be able to abide that. Okay, next let's see a demo how to set up a cluster in the Google environment. Hello. So for the purpose of this demo, I have created a Kubernetes cluster in the Google Cloud environment. So I'll also show you how to create a Kubernetes cluster. Okay. So just go to create. You can click the standard configuration. I'm just accepting it. Okay. You can give a name for the cluster. You can choose a region and zonal information here. Okay. And also coming to the default pool, it has 3, that is nodes. So you can define your nodes here. So since it is a demo, I'm just accepting the node with the E2 series, which is a general purpose node, which has 2 core and 4 GB RAM. If you're planning to do for a production, you should go for other instances like compute optimized or memory optimized for your workload. So I'm just giving create. Okay, so the creation will take time, so I'm not going to concentrate on that. We'll use the existing cluster which is being connected. So I'll connect through the Google Cloud Shell. Okay, so I'm just giving the authorization to connect via the Cloud Shell. So now our Cloud Shell is ready. Let's see the nodes. So I have configured a 3-node cluster, right? Okay, so my 3-node cluster is ready, and let's go and deploy the cluster. First, let me clone the repository of operator from the Git. I have all my commands ready here. Okay, so cloning is completed. You can see the MySQL operator is here. I'll just move to the MySQL operator folder. You can see the list of folders here: deploy, gen, and helm. So for this demo, I'll be completely using the manifest file for the deployment. I'm not going to use the helm chart. So first I'll deploy the prerequisite. So that is the custom resource deployment. You can see here. So let me apply this kubectl. So first I'm defining the custom resource definition. As you can see, the custom resource definition got created, which is required for the operator. And as a next step, I'll deploy the operator itself. So the command is simple, just the same command, deploy operator. Yes, now our operator is ready. Let's check the operator status. Okay, now our operator is ready to, and it's ready to serve, or we can proceed to create the cluster with this. I'll change the folder. Samples. Okay, as a first step, we'll create the secrets. The secret is nothing but a credential manager that lies within the Kubernetes. Okay. As you can see, I'm giving the user as root user and host as an anonymous host, and also the password is a less strengthened password. While you are deploying for the production, take care of these things with respect to the particular host as well as use a strong password. Okay. As you can see, my secret is created. I have named the secret as MyPyds. Okay, this is my secret name. As the next step, we'll launch the cluster itself. I'll show you the YAML file which I am going to use to launch the cluster. Sorry. Okay, so this is the YAML file wherein my kind is InnoDB cluster. I'm going to launch an InnoDB cluster, and I have named the cluster as my cluster, and I'm going to use the same secrets which I have created earlier, and I'm going to create a 3-node InnoDB cluster, and I'm going to create a router instance as 1. Okay. So the command remains the same. I'm just going to apply this YAML file. As you can see, it states that the cluster is created. Okay. Now let's see the kube status. Okay. You can see my pods are getting created. It is getting initialized. Okay, so out of this, one node will get initialized first. That means that will be our primary node, and the remaining nodes will be our secondary. So you can see initializing. You can see the my cluster 01. It is getting initialized first. It is running the first step of the init process out of the 3. Okay, you can see it is almost ready. It is the next step. Okay. As the second init process complete, the other nodes, that is a cluster 1 node and the cluster 2 node kicks in, and they also begin their init process to connect to the cluster. Okay, so node 1 is almost ready.
You can see the time that these are the time which is taken to completely clean the cluster audio. It is a pod Our primary node is completely ready. You can see it is ready to out of 2 and the starting is ready. Now our complete cluster is provisioned. The next will take around 1 or 6 seconds to completely provision and ready to clear the cluster. And as a next step, the only thing remaining is the router configuration. The router node will get ready soon because it's in stateless application. Just the container will be created as configuration started. Yes. So our URL cluster is complete. So now let's see the services. So service is nothing but the network discovery, that means the network that is being allocated to the cluster. You can see my cluster has been assigned an IP of 10.16.25, so that is the IP I should collect. And also you can see the code that is being published, 3806 for the node communication, and 6446 is our router RO code, that's our read-line code, and 6447 is our read-only code with respect to the cluster, and 6448 and 6449 are the hex protocol code. Now let's connect to the cluster directly and just connect to one of the nodes. To connect to the node, I'm just running a temporary MySQL client container. my client container is ready. Now I'm going to connect to the VM. So here I'm connected to one node of the cluster. That is the primary node. Now let's see the cluster status. You can see our cluster is completely ready and it is ready to accept the project. Okay. Now let's see how to upscale the machine, that means adding a node to the cluster. It is very running time. If you are trying to upscale anything, let's see how the number of things to do. I'm working with this file. I'm making this file. I'm just again applying the same. You can see that other two nodes are getting started. So this is how you upscale the instance with respect to the database. Thank you. That's all we have for today. Any questions?
I have a question. I have let's say 6 terabytes of data in a data. So can I run those on Kubernetes cluster?
So now you have to
So you actually have 6 terabytes of data that you run in Kubernetes.
okay. See, again, the question of running to the Kubernetes, moving towards the Kubernetes depends upon your use case. Basically, if you're having a 6 terabyte, right, I would recommend running on a VM, not to go towards the Kubernetes, because the volume and the consumption increases. In the physical volume, that is the processing volume, which we discussed by the Kubernetes, right, there is a limitation. That means once you allocate, right, the initial allocation, so that is the itself. You cannot upsize the instance. That means like the volume does not grow dynamically. It is a fixed set. If you want to dynamically grow, you have to just completely destroy the volume and create a new volume class and then migrate. So it's difficult to maintain. That's what it is. Difficult to maintain a big class of machine or a huge database onto Kubernetes. This kind of a system is well suited for a microservice tool. For example, when you have a small application, a very simple application like a transaction or a small car. So the microservice architecture scales well with the Kubernetes as well as for the particular databases.
That how it is, right?
Sorry?
Microservices are in like service. Microservices are a stateless service, right? Like recently, other database services are a stateless service. So how, what is the recommended way to do? Like what kind of database services you can onboard on the Kubernetes?
It actually depends on your organization and the load and use case which you are trying to solve at a particular Kubernetes. So for example, you have a macro service, like if your database is completely monolithic, like for example, it is a single monolithic application that completely manages your application, I would recommend not to move to the Kubernetes. So if you are planning to move for a microservice architecture, you segregate your database with respect to the microservice what you have, then you can follow this Kubernetes approach. So that would be the easy way of scaling. Thank you.
So this Kubernetes is available only on GCP.
No, it's available in Amazon. Also, you can bring up your own physical machine if you install the Kubernetes and you can deploy your pods.
Can I use it for any migration?
Yes.
From Oracle to
Yeah, you can use it. It's basically the container. The container and you can just import it to the or use your
for watching the Mydbops Open Source Database Meetup 12th edition. To subscribe our channel, press the bell button, like, comment and share.